A rational expression is a quotient of two polynomials. We write that quotient as a fraction with a polynomial in the numerator and a polynomial in the denominator. When we multiply and divide rational expressions, we use the multiplication and division property of fractions. So let's review those properties. The multiplication property of fractions says that if I have C over D times N over M, the answer is equal to C times N over D times M. Of course, our denominators D and M do not equal to 0. Basically, what this says is that to multiply fractions, we multiply numerator times numerator and denominator times denominator. Now let's look at the division property of fractions. If I have A over B divided by S over T, I rewrite my first fraction A over B as it is, and I multiply by the reciprocal of my second fraction. S over T is my second fraction. The reciprocal of S over T is T over S. This A over B times T over S is an equivalent multiplication problem to this division problem. And of course, once I write the equivalent multiplication problem, I use the multiplication property of fractions that tells me to multiply numerator times numerator, so I get A times T, and denominator times denominator, so I get B times S, or BS as the denominator. Once again, my denominators B, T, S do not equal to 0. As when we multiply rational numbers, we reduce our answers to lowest terms. When we multiply and divide rational expressions, we want to make sure that our answers are reduced to lowest terms. If you'll recall from our previous lesson, when we reduce rational expressions, we divide out common factors in the numerator and denominator, and we use our laws of exponents. Let's look at the reduction property of fractions. Recall that it says that if I have A times X over A times Y, that I can divide out this common factor A and that the result is X over Y. So A times X over A times Y is equal to X over Y. Once again, our denominators do not equal to 0. Remember that we have to be careful. We may only divide out common factors. Now let's begin working some problems. The typical instructions for these problems would say perform the indicated operation, and I am supposed to recognize that I have a rational expression times a rational expression. The indicated operation is multiplication. Well, I know the rule for multiplying fractions is numerator times numerator and denominator times denominator. So I may say 8 times 9 is 72. I have x to the 4th, y times z cubed in the numerator. In the denominator, I'll say 4 times 6 is 24. Let's write these variables in alphabetical order. Let's write the w, then let's write the y to the 8th, and then the z. Now let's divide out common factors and let's use our exponent laws. 24 is a factor of 72. 24 goes into 72 3 times, and 24 goes into 24 once. As far as my x to the 4th, there's not anything I can do with that, but look at my y's. Let's go ahead and let's rewrite the 3. Let's write the x to the 4th. I know that y divided by y to the 8th, since I have more factors of y in the denominator, it stays in the denominator. And to get the power, I use my division law of exponents that says I subtract my exponents. So I'll say 8 subtract 1. For my z's, I have more factors of z in the numerator, so my z stays in the numerator, and I'll use my division law for dividing like bases that says that I subtract the exponents, so I will say 3 subtract 1. I have a factor of w that stays in the denominator. So let's rewrite this. We'll have 3 x to the 4th, z to the 3 subtract 1 gives me 2, over w, y to the 8 subtract 1 gives me 7. And since the only common factor now for the numerator and denominator would be the integer 1, this is reduced to lowest terms. Now, I would like to suggest another way that we could work this problem. We can divide out common factors actually before we multiply. Let's look at this. I've got the 8 x to the 4th y over 4z times 9z cubed over 6 y to the 8th times w. To divide out common factors before I actually multiply, I have to make sure that my numerators and denominators are in factored form, and indeed 8 is a factor, x to the 4th is a factor, y is a factor, and my other numerators and denominators are in factored form. And then dividing out common factors, I could say 4 goes into 4 once, 4 goes into 8 twice, 3 goes into 6 twice, 3 goes into 9 3 times, and 2 still is a common factor. I can say 2 goes into 2 once, 2 goes into 2 once, and divide out those common factors. That saves me having to work so hard on the arithmetic in the end. What I end up with in the numerator then would be x to the 4th times y times 3 times z cubed. Let's write the 3, the x to the 4th, the y, the z cubed. In the denominator, I have 1 times z times y to the 8th times w. So let's write the w, y to the 8th, and then the z. Now, I prefer on my variable factors, when I have powers greater than 1, to go ahead and multiply my numerator times numerator, denominator times denominator, and then use my exponent laws. So then I would say that y divided by y to the 8th would be y to the 7th. Z cubed divided by z would be z squared in the numerator, and of course the w stays in the denominator. And notice that I get the same answer that I got before. I just didn't have to worry about the second way that I worked the problem, figuring out that 24 was a factor of 72, and I think maybe that's a little easier. Let's look at problem number 2. Perform the indicated operations, and I have a fraction divided by another fraction times another fraction. Well, the first thing that I'm going to do is to rewrite this. I've got 12b c to the 7th over 2a squared d to the 5th. And I am to divide by this second fraction. But my division property of fraction says that when I divide, I multiply by the reciprocal. So let's write the reciprocal of 9b to the 5th c over 8a to the 8th d to the 5th. The 8a to the 8th d to the 5th comes to the numerator, and the 9 b to the fifth c goes to the denominator, and then I have times my third fraction, 3a cubed over 16b c to the fifth. Now, since this is all multiplication, and since my numerators and denominators are in factored form, I'm going to go ahead and divide out my common factors in my numerators and denominators for my numerical coefficients. There are a lot of things I could do here. Let's say 2 goes into 2 once and into 12 6 times. Let's say 3 goes into 3 once and into 9 3 times. Let's say 3 goes into 3 once and into 6 2 times. Let's say 8 goes into 8 once and into 16 2 times. And now look at my 2's. 2 goes into 2 once, 2 goes into 2 once. So I have completely divided out all of my numerical common factors. Next, I'm going to look for my variables. And if I have any variables in the numerator that are raised to exactly the same power as variables in the denominator, I think I'll go ahead and divide them out. Let's say b goes into b once, b goes into b once, so I can divide out that common factor of b. The d to the fifths, I have d to the fifth in the numerator and d to the fifth in the denominator. Do I have any exact other factors? Well, I don't think so. So let's see what I'm left with. In this numerator, I have c to the seventh times a to the eighth times a cubed. Well, let's go ahead and say a to the eighth times a cubed is a to the... Remember, when we multiply like basis, we add their exponents. 8 plus 3 gives me 11. And then let's write the c to the seventh. In the denominator, I have an a squared, a b to the fifth, a c, and a c to the fifth. Let's write the a squared, b to the fifth, and let's say c times c to the fifth would be c to the sixth, adding the exponent of 1 to the exponent of 5. Now, let's use our division laws for dividing like basis. I have a to the 11th divided by a squared. I have more factors of a in the numerator, so my a stays in the numerator, and when I divide like basis, I subtract the exponents. 11 subtract 2 will give me 9. On my c, I have more factors of c in the numerator. I have c to the seventh divided by c to the sixth. Since I'm dividing like basis, I subtract the exponents. 7 subtract 6 would give me 1, so I don't need to write the 1. And of course, my b to the fifth stays in the denominator. So I have divided out all common factors, of course, except 1. So this is reduced to lowest terms. In our first two problems, our numerators and denominators have contained polynomials that were monomials. Now I'd like for us to look at some problems where the numerators and denominators are binomials, trinomials, or even in one case, one of our numerators has 4 terms. Let's look at problem number 3. We are to perform the indicated operation. We are multiplying rational expressions. When we multiply rational expressions, we know that we want to multiply numerator times numerator and denominator times denominator. We also know that we need to reduce to lowest terms. When we have binomials or trinomials or more than one term in the numerators and denominators, what we need to do is factor first. So let's factor these numerators and denominators. For my first numerator, I simply have 5 minus x. In the denominator, I'll take out a common factor of 4. I'm left with 2x plus 3. I want to multiply that by, now let's factor the numerator of my second fraction. Let's factor out a y. I'm left in the first term with 2x and in the second term with plus 3. And in the denominator, I want to factor out a common factor of 4, and then I'm left with x minus 5. Now, when I say numerator times numerator and denominator times denominator, because I know I'm going to have to reduce to lowest terms, it's much better just to leave this in factored form. Let's go ahead and write that 5 minus x with parentheses. So when I say 5 minus x times y times 2x plus 3, I'm going to write the y, I'm going to write the 5 minus x, and then I'm going to write the 2x plus 3. In the denominator, I'm going to go ahead and say 4 times 4 is 16, and then I'm going to write my variable factors, 2x plus 3, and then x minus 5. Now, I want to divide out common factors, so I can see that 2x plus 3 is a common factor for the numerator and the denominator, and look at my 5 minus x and my x minus 5. Those are opposites, aren't they? Well, what I want to do then is to factor a negative 1 out of either my numerator factor or my denominator factor. Let's go ahead and take it out of my numerator factor. When I factor negative 1 out of 5, I'm left with negative 5. And when I factor negative 1 out of negative x, I'm left with a plus x. And then I have my factor of 16 and my factor of x minus 5. Let's rewrite this. Let's write the negative 1, and then let's write the y. And then for this binomial factor in the numerator, let's use the commutative property to write the x term first and then the minus 5. And look, I have a common factor of x minus 5 that I can divide out. I'm left with negative 1 times y over 16. Of course, negative 1 times y is just negative y over 16, and you may write it like that, or you may write the negative in front of the fraction and then write the y over 16. Now, very often I skip this step right here, because what have I really done here? Basically, all I've done is rewritten the factors in the numerator and rewritten the factors in the denominator. Yes, I did multiply the 4 times 4 to get 16. But at this step right here, since I have my numerators and denominators in factored form, if I see a common factor in the numerator and denominator, I can go ahead and divide it out. For the rest of these problems, after I have factored the numerator and the denominator, I'm going to go ahead and divide out the common factors. Okay, let's look at problem number 4. The indicated operation for this problem is division, and once again I am dividing rational expressions. Now, I know that first I want to rewrite this as its equivalent multiplication problem. So let's write 10x squared y minus 4x squared over 21x plus 84 times, and let's write the reciprocal of the second fraction, which would be 7x plus 28 over 5xy minus 2x. Next, we want to factor these numerators and denominators. For this first numerator, let's take out a common factor of 2x squared. That leaves me with a 5y in the first term, and in the second term I'll have subtract 2. In the denominator I have a common factor of 21. Factoring 21 out of the first term, I'm left with x plus, and factoring 21 out of 84, I'm left with 4. For the numerator of my second fraction, I have a common factor of 7. I'm left with x plus 4. For the denominator of my second fraction, let's take an x out. We're left with 5y minus 2. Now that I have these numerators and denominators in factored form, let's go ahead and divide out common factors. I can divide out the 5y minus 2 and the x plus 4. Let's say 7 goes into 7 once and into 21 3 times. Now let's write what we have left in the numerator. Actually, at this point, we now say numerator times numerator, denominator times denominator. But since we've divided out all the factors in this numerator and we're understood to have a 1 left when we divide out, what we will have here is 2x squared times the understood 1, which is 2x squared. In the denominator, we'll have 3 times x, which is 3x. And last, what we need to do is to use our exponent law for dividing like bases. So we will have 2 over 3, and for the x squared divided by x, since I have more factors of x in the numerator, the x stays in the numerator, and when I divide like bases, we subtract the powers. We'll say 2 subtract 1, which leaves us with the power of 1, and we don't need to write it. So the answer here is 2x over 3. I'd like to caution you, when we're dividing rational expressions, our first step is to rewrite the problem as its equivalent multiplication problem. We multiply by the reciprocal first, then we factor, then we can divide out common factors. So be sure you multiply by the reciprocal, then factor, then divide out common factors. Also remember that we can divide out common factors, but we cannot divide out terms. The reduction property of fractions says that we may divide out common factors, not terms. Now let's look at problem number 5. I have a multiplication problem. Let's factor. This first numerator is the difference of cubes. It factors into a short factor and a long factor. For that short factor, my first term is whatever I've cubed in this first term, which is a. Then I have the minus sign, and then I have a b. For my second factor, I square the a. My next term has the opposite sign, has this minus, so I know it'll be plus. I say a times b, and last I square the b. In the denominator, I have a general trinomial. To factor 2a squared, I'll use 2a times a. For the b squared, I want to use b times b, and I know that these b's are going to have different signs because there's a minus sign in front of the b squared. Well, let's see, where does the minus need to go? I believe the minus needs to go here and the plus needs to go there. For my second fraction, when I look at the numerator, I recognize that that's a perfect square trinomial. It factors as a binomial square. I'm going to write it as a plus b times a plus b. And for the denominator, it's the difference of squares. It factors as a plus b times a minus b. Now that I have factored my numerators and denominators, I may divide by common factors. I have an a minus b in the numerator and an a minus b in the denominator, an a plus b in the numerator, a plus b in the denominator, and a plus b over a plus b. I am left in the numerator with a squared plus ab plus b squared, and in the denominator with 2a minus b. For problem number 6, we are dividing. Remember, first step, let's rewrite this problem and multiply by the reciprocal of the second fraction. So the reciprocal would have 2x squared minus 9x plus 4 in the numerator, and 4x squared minus 28x plus 48 in the denominator. Let's factor this numerator. Let's take a common factor of 4 out. That will leave us with x minus 3. In the denominator, we'll have 2x times x, and a 1 and a 5. The sign in front of the 5 needs to be positive, and in front of the 1 needs to be negative. For the numerator of the second fraction, we'll have 2x times x, and a minus 1 and a minus 4. And for this denominator, it has a common factor of 4. Let's take that common factor out and just show our work right here. Let's see, we'll have x squared minus 7x plus 12, won't we? So let's write our 4, and then let's factor the x squared minus 7x plus 12. It will factor as x minus 3 times x minus 4. Now let's divide out common factors. We have common factors of 4, common factors of x minus 3, common factors of x minus 4, and common factors of 2x minus 1. Now, what are we left with in that numerator? Well, in that numerator, we're understood to have a 1, and then in the denominator we have x plus 5. So that's our answer. In problem number 7, we are dividing. We have a rational expression divided by a polynomial. First thing I want to do is to write this polynomial as a fraction, and of course I may write it simply as x plus 3 over 1. Next, since it's a division problem, we want to rewrite this problem and multiply by the reciprocal of that second fraction. So the reciprocal of x plus 3 over 1 would be 1 over x plus 3. And of course that x plus 3 is a factor, so let's put the parentheses around it. For the numerator of this first fraction, when I get ready to factor that, since there are 4 terms I know to group, I'm going to group those 2 and then the third and fourth terms. In the first 2 terms, let's factor out an x squared. And that will leave us with x plus 2. In the third and fourth term, let's factor out a minus 9, and that will leave us with x plus 2. And let us note that after we have grouped, what we have here is not considered a factorization. This is still a difference. I still have 2 separate terms in this numerator. So I can't start dividing out common factors until I have completely factored that numerator. So we'll work on that some more in a minute. On the x squared plus 4x plus 4, once again, that's a perfect square trinomial. It factors as a binomial square, and I'm going to write that as x plus 2 times x plus 2. And of course, I can't do anything else yet with that second fraction, can I? Now let's work on that first fraction, the numerator of that first fraction. Again, we want that numerator to be completely factored. So in this numerator, I have two terms. Those two terms have that common factor of x plus 2. So I factor that x plus 2 out, and I write what's left. In the first term, I'm left with an x squared. In the second term, I'm left with minus 9. Now notice, yes, my numerator is now a product. It is considered to be in factored form, but it's not completely factored because x squared minus 9 is the difference of squares. So we need to factor again. Factoring the x squared minus 9, we'll have x plus 3 times x minus 3. And now I've got that numerator completely factored, don't I? Now let's divide out common factors. I've got an x plus 3 and an x plus 3 and an x plus 2 and an x plus 2. We are left with x minus 3 times 1, which is x minus 3 for a numerator, and in the denominator we're left with x plus 2. Now I would like for you to work problem number 8. I'm going to put it on the screen, copy the problem, pause your tape, and work the problem. After you've had time to work it, I will work it so you can check your work. But now, if you will, look at your screen for problem number 8. How did you do? Let's work problem number 8. We are to divide. Let's first rewrite this. We'll have x squared minus 1 over x squared plus x minus 12 times the reciprocal of the second fraction, x plus 4 over 4x minus 4x squared. Now let's factor. For our first fraction, our numerator is the difference of squares. It factors as x plus 1 times x minus 1. In the denominator, we have a trinomial with a leading coefficient of 1. It factors as x plus 4 times x minus 3. For our second fraction, our numerator is a prime factor. Our denominator has a common factor of 4x, and let's factor the 4x out, and then we're left with 1 minus x. Now we do have a common factor in the numerator and denominator, the x plus 4, but notice your x minus 1 and your 1 minus x. They're opposites, aren't they? So what we do when we have opposites is factor a negative 1 out of either the x minus 1 or the 1 minus x. I'm going to choose to factor the negative 1 out of the x minus 1 in the numerator. So we'll have x plus 1. Let's write our factor of negative 1. And let's factor that negative 1 out of x minus 1. When we factor a negative 1 out of x, we're left with a minus x. And when we factor it out of negative 1, we're left with a positive 1. Remember that when we factor a negative 1 out, what happens is we change the signs of the terms. Notice x was positive, here it's negative, there it's negative, and here it's positive. That's what factoring a negative 1 out of an expression will do. In the denominator, we have x plus 4 times x minus 3. Then we'll have x plus 4 over 4x. And when we write this binomial factor in the denominator of the second fraction, let's reorder the terms. Let's write the minus x first and then the plus 1. Now let's divide out common factors, the x plus 4s and the minus x plus 1. We're left in the numerator with minus 1 times x plus 1. In the denominator, we will have 4x times x minus 3. Now usually what we do with this minus 1 factor is we write a negative in front of the fraction, and then we'll write the x plus 1 in the numerator and the 4x times the x minus 3 in the denominator. This completes the multiplication and division of rational expressions lesson. Please rewind the tape before you return it. Thank you.